What's up, everybody? Welcome back. In this question, we're given two functions and we have to describe the difference between them in words and through a graph. So we got f of x is 2x plus 1 and then g of x is 2x squared plus x over x. Now, this is just a linear function, right? Y equals mx plus b. So this one would be pretty easy to graph. Plus 1 is the y-intercept. And then we have a slope of 2. So it's like 2 over 1. So we're rising 2, running 1, rising 2, running 1. So we could just draw a line like this. It's going through that y-intercept of 1. So this point here is 0. And 1, and maybe another point would be if we rise 2, run 1, we'd have 1 and 3, for example. Right? If you do it on graph paper, it's going to look a lot nicer. So just a simple linear function here. Now, this here, because we have a variable in a denominator, this is a rational function. Okay, so what you want to do here is you want to always check if you can simplify. So what do? We make sure that we can that everything is factored first. So notice the numerator, we could take out an x. We'd be left with 2x plus 1. And it would be over x. And then, before simplifying, you want to get the restrictions. So notice in this case, x cannot equal 0. Right? You can't have the denominator equaling 0 because if you're dividing by 0, it would be undefined. And then, after you have the restriction, you simplify. So notice this x cancels out, and we're left with 2x plus 1. That's what it simplifies to. Notice that this is the same as this. So what's going on here? Are these two the same? Well, almost. The thing that makes them different is this restriction here, where x cannot equal 0. And if you remember from the lecture videos, when factors cancel out like this, the restriction from that factor is always a hole in the graph. So we would actually redraw this line, 2x plus 1. But there would be a hole at an x value of 0. X value of 0 is here. So right there on the y-intercept, actually, there is a hole like that. Okay, what if there was another factor that canceled out, like x plus 3? X plus 3, like that. Those canceled out. Well, there would be another restriction, x cannot equal negative 3, and then at an x value of negative 3, which is about there, because the x-intercept is negative 1/2. So yeah, negative 3 would be over here. There would be a hole at negative 3 right there as well. Right? So any factors that cancel out, the restriction is always a hole. All right, so in words, this is a rational function that simplifies to a linear function, but there's a restriction of x cannot equal 0, which means this represents a hole on the graph. So the graphs are pretty much the same except for that hole. There's no hole here. Another difference that you could state is the domain and range. The domain for this line here with no restrictions is just what? XER. And then what's the range? YER. Y can be anything, X can be anything, right? This keeps going on forever and ever. What's the domain and range here? The domain would be X can be anything except x cannot equal 0. So anything other than 0, we're good, but x cannot equal 0. And then what would the range be? Y can be anything, but y cannot equal positive 1. Because here, this hole is happening at 0 and 1. So that y value of 1 cannot exist either. But other than that, y can be anything. So that's another difference, the domain and range of both of these. Right? So it's the same line. This line has a hole at an x value of 0 because that x canceled out. Here, there's no restrictions because it's simply a linear function.